Good morning, guys. I'm sorry that I won't be in class today, but I'm going to make you a video so that you won't get behind. Okay, so if you'll take out these notes and kind of read and follow along, notice it says that we have this point at 4, 2, which happens to be right here. And then it says that it's on this curve, so that's already graphed for you. And it wants the equation of the line tangent. Okay, so if you remember, we did this last Friday. You need a point and you need a slope. So I'm going to make this little chart. The point is given, and then the derivative at x equals 4, if you put that, again, you'll have to do that in your calculator, it comes out to be 2. Okay, so again, I'm just going to draw that in so you can kind of see it. From this point, if I go with a slope of 2, you can see that we get this tangent line, okay? And we can find the equation of the line by doing y minus y is equal to m times x minus x. Right, so putting in those respective numbers, I get 4 minus 2 is equal to 2 times x minus 4. And again, this part's review, completely not new. We get 2x minus 6. Okay, now if you remember, a normal line is just perpendicular. So I'm going to draw that in for you. Perpendicular is going to have a, actually I'm going to find the slope first. The perpendicular slope is not going to be this, it's going to be its opposite reciprocal. And if I draw that in, you can see that this green line ends up being perpendicular to the red line. Okay, so if we write the equation, right, now it's asking us, hey, can you write the equation of the normal? Again, you need a point, which is, let me see if I can find a highlighter here. Here's the point. Right? And then here's the slope. So writing the equation, I'm going to have y minus y is equal to m times x minus x. I'm going to distribute. I'm going to move this to that side, and I get negative 1/2 x plus 4. And again, if you look at my picture, you can see that slope of negative 1/2. You can see the y-intercept of 4. Okay, so we're going to try a couple more of these. Again, notice, this is very, very important, that it wants the equation of the normal, okay? And this time it's asking for answers in standard form. So, because it wants the equation of the normal, I'm going to kind of change my table here a little bit, and I'm going to put perpendicular slope for the last one. So the point is given, the derivative when x is negative 2, this is where you have to use your calculator. For this one, it comes out to be negative 5. And then that makes the perpendicular slope the opposite, so it's right opposite of this one, so it'll be positive, and then the reciprocal. And when I go to write the equation, the things I'm using are this point and this slope. So y minus y is equal to m times x minus x. I'm going to distribute. And then because here, this is kind of different, it's saying, hey, put this thing in standard form. That means I can't have any fractions. So I'm going to multiply everything by 5. And then standard form also says that the x term has to be positive, and since it's already positive on this side, I will move these things to the other side. So I will have, what, x plus, oh no, not plus, minus, let's see if I have an eraser here, minus 5y, moving that over, plus 22 equals 0. Okay, so my suggestion at this point is to pause, try the next problem, and then unpause. Point, slope, perpendicular slope. All right, so again, point is given, the derivative with respect to x when x is negative 1. Again, this is where you use your calculator. This one comes out to be 12, which means our perpendicular slope is negative 1/12. Okay, here we go. Using, and again, let me highlight that for you. Using this and this, I'm going to have y minus y is equal to m, that's not a 13, what am I doing? 12x minus x. I'm going to distribute. I'm going to fraction bust because standard form cannot have any fractions. Negative x minus 1. All right, and I'm going to move these to this side again because the x has to be positive. So I'm going to have x plus 12y minus 71 equals 0. All right, there's the problems. You can see them down here at the bottom of the page, and I will see you on Wednesday.